Today we will continue with the multiplication of radicals, specifically when radicals have a different index. So remember, radicals must be transformed or converted in order to have the same index to be possible to multiply it. So this one is the first topic that we will need to transform them, because in last videos they have always the same index and we only like need to put it on the same uh, radical and then take it out. In this case, we first need to transform them. How do we transform it? It says we must look for a least common multiple between the index, and then we will transform our radicals in order to have a common index. To do this, we must write the term inside the radical. We will see how to do it with an actual exercise, but the idea is going to be that we will raise the terms that we have inside our radicals in order to be converted from one type of radical to another. So let's see. On the first one, the first thing we need to do always is we need to decompose our radicals. So if we decompose the 18, divisible by 2, it's 9, 3 is 3, 3 is 1. So it's going to be 2 that multiplies 3 squared that multiplies x. The other one is going to be 3 that multiplies the cubic root of 20. Let's decompose the 20. 2 it's 10, 2 it's 5, 5 it's 1. So it's going to be 2 squared that multiplies 5 that multiplies x squared. So let's look for the least common multiple between the index. The index are 2 and 3. So of course the least common multiple between them, it's going to be 6. So we need to transform our radicals to sixth radical. Of course, this number 3 will stay the same because it's outside the radical, so it's not transformed. How do we transform it? Let's see. We have an index number 2 that now will become an index number 6. 2 to become 6, I multiplied by 3. So here I multiplied by 3. That means whatever it's inside my root, I need to rise it to the third power. So if I rise 2 to the 1 to the third power, it's going to be 2 to the 3. If I rise 3 squared to the third power, it's going to be power of a power. They get multiplied. 2 times 3 is 6, so it's going to be 3 to the 6. X is going to be x cubed. What happens on the other one? 3 to become 6, it's multiplied by 2. That means we need to square whatever it's inside the radical. So 2 squared is squared again. It's going to be 2 to the 4. 5 to the 1 squared is going to be 5 squared. X squared is going to be x to the 4. Now we can put it in a single same root. So it's going to be 2 to the 3 and 2 to the 4. It's going to be 2 to the 7. 3 to the 6, it will stay as 3 to the 6. 5 squared will stay as 5 squared. X cubed, x to the 4, it's going to be x to the 7. So what happens next? I'm able to take out something from the root. So it's going to be 3 that multiplies whatever I can take out from the root. I can take out a 2, I can take out a 3, and I can take out an x. And on the inside part of the root, I will still have a 2 because 7 divided by 6 is not an exact division. The remainder is 1. 5 squared, of course, cannot go out because the power is smaller than the index. And in the case of the x, 7 divided by 6 is going to be 1 and the remainder is 1. So 1 is still inside the root. So my final answer of this one is going to be 3 times 3, 9, times 2, it's 18. X that multiplies the 6th root of 5 squared times 2, it's 50. 50x. And that's going to be my actual answer. So what is the idea that is going to be very different from other exercises? We need to transform our radicals in order to have the same index. How do we do it? The number that I need to multiply the radical to become the other one, it's the number that I will raise the terms that are inside the radical to that power. In this case, this one I raised every term to the third power. In this one, I raised every term to the second power, and then it will become a normal exercise of multiplication of radicals with the same index. Let's see another example. So on this exercise, first we need to decompose whatever it's inside the radical. So it's going to be, this one will stay exactly the same. The second one, we can decompose the 4. So the 4 is going to be 2 squared x cubed y if I put it in alphabetical order. Now we need to look for the least common multiple between the index. In this case, 5 and 2, of course, is going to be 10. So the index that is going to be the common index is going to be 10. So we need to transform our specific roots to have the root of 10 or the 10th root. The 2 and the 4 doesn't change because they are coefficients. They are not inside the root. So what happens here? 5 to become 10, I need to multiply it by 2. So that means I will raise what is inside to the second power. 4, rise it to the second power. It's going to be power of a power. So it's going to be x to the 8, y to the 6, because it's 3 squared. I mean, something that is to the 3 squared is going to be something that will be to the 6. Here it's going to be 2. To become 10, I need to multiply it by 5. That means I will raise to the power of 5 whatever it's inside. So it's going to be 2 to the 10 because I need to multiply the power by 5. X is going to be to the 15 and y is going to be to the 5. That means we can put it in a single one. So the coefficients will multiply. 4 times 2 is going to be 8. That multiplies the 10 root, and let's see. The number 2 to the 10 stays because we don't have nothing else to multiply. X15, x to the 8 is going to be x to the 23. Y to the 6, y to the 5 is going to be y to the 11. Now we can take out whatever is possible to take it out. So we can take out, in this case, a 2, an x, and a y. And in the inside part, I will still have x to the 3 and y. Why? Because 23 divided by 10 is not an exact division. The remainder is 3. 11 divided by 10, it's not an exact division. The remainder is 1. So that's why our final answer on this one should be 16xy that multiplies the 10 root of x cubed y. And this one, it's going to be my final answer. So as I was telling you on the last exercise, the idea is we need to change our radicals in order to be the same radical. How do we do it? The number that we need to multiply is the number that we will raise the terms inside that radical. Let's see another example. So this exercise is going to be with polynomials, but it's going to be exactly the same. It's going to be exactly the same. So how do we do it? First, we need to factorize it or decompose the radical. So here we can take out a 3x, and it's going to be x minus 4. On the other one, of course, this one will multiply the cubic root of, first we can take out a 3, and it's going to be x squared minus 8x plus 16. So we can factorize it again, and it's going to be 3x that multiplies x minus 4. Then it's going to be the cubic root of 3 that multiplies. The trinomial that we have there, it's a perfect square trinomial because the first one has a square root that it's x. The third one has a square root that it's 4. If I multiply those times 2, it's going to be the middle one. So we can decompose it like this. So we have the index number 2, the index number 3. So the least common multiple is going to be 6. So we need to transform to have index 6. So this one, 2 multiplied by 3, it's 6. So we need to raise every term that we have there to the 3. So it's going to be 3 to the 3, x to the 3, and x minus 4 to the 3. What happens on the other one? 3 to become 6, we need to multiply it by 2. So we will raise them to the second power. So it's going to be this one to the second, this one to the 4, because 2 times 2 it's going to be 4. So now we can put it in a single root. It's going to be 3 cubed and 3 squared. It's going to be 3 to the 5 x cubed, and it's going to be x minus 4 to the 7. So let's see if it's possible to take out something. Of course, it's going to be possible to take out something. I can take out an x minus 4. On the inside part, I will still have 3 to the 5 x cubed and 1x minus 4, because 7 divided by 6, the remainder is 1. So my final answer is going to be x minus 4. If I do 3 to the 5, it's 3 times 3 times 3 times 3, 5 times. And it's going to be 243 x cubed. That multiplies x minus 4. And that will be my final answer. So if we have polynomials, it's exactly the same procedure. We need to first decompose it, then we will transform them in order to have the same common index. How do we do it? The number that we need to multiply to become the other, it's the number that it will be raised, whatever it's inside our radicals, and then we will be having a normal multiplication of radicals with the same index. Let's do one last example. So let's see here. It's something very similar. First, we need to decompose what we have inside the radicals. So here it's going to be the cubic root of 5 squared x squared y. If I put it in order, that multiply is going to be minus 10 x squared divided by 9. And on the inside part will stay exactly the same, 3 divided by 5xy. So now we have a square root and we have a third root. So the least common multiple is going to be 6. So we need to transform it to 6's. We need to transform it to 6's. So it's going to be something like this. Remember, those that are outside the radical, it won't change because they are coefficients. They are not part of the radical. So here, these 3 to become 6, we multiply it by 2. So everything inside will be raised to the 2. Something that is squared raised to the 2 is going to be to the 4. To the 4, to the 2. And in the other one, it's going to be 3. This one gets multiplied by 3, so it's going to be 3 cubed divided by 5 cubed x cubed y cubed. So what do we need to do next? We will multiply the coefficients. So we will multiply 3 over 5. That multiplies minus 10x squared over 9. So of course, we can decompose the 10 and the 9. The 10 is going to be 5 times 2. The 9 is going to be 3 times 3. So we can eliminate this 3 with this 3, this 5 with this 5, and our answer is going to be minus 2/3 of x squared, or x squared on top. So it's going to be minus 2x squared divided by 3. And on the inside part of the root, I will have, on top, I have 3 cubed, 5 to the 4. That multiplies x to the 4 y squared. On the bottom part, I have 5 cubed x cubed y cubed. So what will happen here? We can simplify it, and it's going to be minus 2x squared divided by 3. We can simplify the inside, and it's going to be 5 to the 4 and 5 to the 3. It's going to be 1 5 on top. The 3 cubed doesn't have anything to be added or subtracted. X to the 4 and x cubed, it's going to be only x on the top. Y squared and y to the 3, it's going to be y on the bottom. So that's why our answer is going to be, I'm sorry, here I forgot the y. I didn't write it here. It should be here. and here. So it's going to be the answer minus 2x squared divided by 3y, all of it that multiplies the sixth root of this one. It's 27 times 5, that is going to be 135 x divided by y, and that will be my final answer. So it doesn't matter that we have fractions or so, the process is exactly the same. We need to transform our radicals in order to have the same radical. How do we do it? We need to rise, in this case, to the second power, in this case, to the third power, in order to become the same index. When we have the same index, we put it in a single root and then take out whatever it's possible to take it out. So this one was the video for explanation of multiplication of radicals with different index.